Okay, we're going to talk about H8D calculating with complex numbers. Um, so, and we're going to be learning something about imaginary numbers. And right now we're going to be talking about, we'll also be talking about Cartesian form. We're going to be writing our numbers in the term of A plus BI, where this is our real portion of a number, and this is our imaginary portion of the number. And we'll talk about that in just a minute. Okay, so far, natural numbers were things that we're counting. 1, 2, 3. Those fit in here. Integers also include negative numbers. So all natural numbers are part of integers. Rational numbers can be written as a fraction. We could write them as a decimal. So all the integers and natural numbers fit in the circle for rational numbers, and real numbers are things that include values that have no that are not rational, that don't have an end to it and don't have a pattern. So that includes real numbers. But we've never talked about imaginary numbers. I'm just going to write IM here for imaginary. And we'll go into that in more greater detail. So in Algebra 2, or in Math 2, you should have practiced with quadratics. And there's this thing called the quadratic formula. There's a song, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So the a represents the coefficient in front of the x squared, the b represents the coefficient in front of the x, and the c represents the coefficient that doesn't have an x. So for example, here my a value is 2. My b value is 2. And my a value is -1. My c value is -1. So now I'm going to plug it into the equation that we have up here. So b, we've got, that's our b's. Our c value is right here. And our a value is right there and right there. Okay. And so if I plug in the a values, the b values, and the c values, it simplifies, and then we end up with -2 plus or minus square root. Okay, this is 4 minus 4 times 2 is 8, and -1, so this ends up being +8. So 4 plus 8 gives me 12. So I end up with, and we could write 12. Square root of 12 is equal to the square root of 2 times 2 times 3, right? And then since I have a pair, I can take it out of the radical, and so I can write it as 2 square root 3. So I can rewrite square root of 12 as 2 square root 3. Okay, so that's what I did here. Okay. So I could write this as -2 plus or minus 2 square root 3, and then over 4. Now, notice I have even numbers in the numerator and an even number in the denominator, so I could simplify it even further. Now, this means, the plus or minus means we have two answers. We have -1 plus radical 3 over 2, and x equals -1 minus radical 3 over 2. So this is our two answers. Okay, you might want to hit pause if you need to copy this down. Okay, question B, same sort of thing. I plug in the a value, the b value, and the c value, and it simplifies, and we've got our two answers. Plus radical 13, and then this minus radical 3 over 13. We have two answers. You might want to hit pause. Okay. Now, same thing, plug in the A, B, and C. What's different in this example is that we end up with 8 squared, which is 64, minus, and then 4 times 60 is also 64. We end up with 0 under the radical. So we only have one answer, so 8 plus or minus 0. So 8 over 2, we have one answer, which x equals 4. Okay, and our last one, like I said, if you need to go back, you can hit pause. Plug it all in. We end up with a negative number under the radical. We're going to talk about that in just a second. So there were no real solutions because there was a negative under the radical. Boo-hoo. But we're going to use our imagination and figure out how to solve this. Okay. So, I'm going to zoom out. So before we get started, the part of the quadratic that is under the radical, under the square root, is called the discriminant. So the discriminant that's under the radical is b squared minus 4ac, if you can recall from the previous page. Okay, so that's going to be important. Okay, so and the other thing that we're going to do is we're going to make a definition that I squared equals negative 1. I also like to write it as I is equal to the square root of negative 1. Okay, this might be an easier way to think of it. And then if I is equal to the square root of negative 1, then I times I is going to equal negative 1. You might want to hit pause and rethink about that. So in our first problem, we got 2i squared. That's going to give me 2 times 2, which is 4, and I times I, which is I squared. And then I'm going to substitute I squared with negative 1. And so now we have the negative there. Now the next one, negative I squared, is negative I times negative I. Negative times negative is going to give me positive. So I've got I squared, and the definition of I squared is negative 1. This one people seem to have trouble with. Negative I times negative I is positive I, so we have positive I squared, and the definition of I squared is negative 1. Okay, negative 2I squared, so negative 2 times negative 2 is 4. I times I is I squared, so we replace that with negative 1. Okay, here are the other answers. Okay, so now x squared equals negative 4. So if I want to solve this using I could write this as x equals negative square root of negative 1 times square root of 4. The square root of negative 1, as we just said, the square root of negative 1 is I. And then you all know that the square root of 4 is 2. X squared minus 9 is going to give me 3i. X squared equals negative 2 is going to give me I radical 2. X squared equals negative 18. So think of that as the square root of negative 2 times 3 times 3, right? 2 times 3 is 6. 6 times 3 is 18. So I've got 3. I can pull the 3 out. The square root of negative 1 is I. And we're left with the 2. Okay. So now we're going to go back to the earlier question B, the one with our sad face, right? So we can say that the square root of negative 16 is equal to 4i, and so now I've got negative 2 plus or minus 4i divided by 2. That can simplify, since both are even numbers, we can divide this by 2 and divide that by 2. Okay, so negative 1 plus or minus 2i. So I've got two answers, negative 1 plus 2i and negative 1 minus 2i. Okay, so we've got a complex root when the discriminant is less than 0. Complex root means there's a real part and an imaginary part. Okay, so here are some other examples. Okay, you might want to hit pause to copy this down or check your answer. Okay, you might want to hit pause to copy this down and check your answers. Okay. All right. Comment on the solutions to each of those equations. So there are two solutions for each problem. Each part has a real part, and each part has an imaginary part on the ones we just did in 6 right here. Okay. Factual. Okay, given one complex solution of a quadratic, how can you find the other one? So what did we do? All we did was we change the sign of the imaginary part. Let's look back at what we did. Notice this one here had 3 plus 2i. This one had 3 minus 2i. This has 2 plus radical 2i. This one has 2 minus radical 2i. Okay. The plus or minus mean the only difference between the two roots is that there is there's a plus and a minus. So we change the sign of the thing to get the two roots. Okay. And why do we need complex numbers? They're going to be essential for electromagnetic waves and circuit calculations, which we'll talk about later. Okay, so we should change this to imaginary roots. Okay, so RE parentheses A plus BI. That just means what is the real part, and the real part is the A. I am A parentheses A plus BI just says what's the imaginary part, thank you. And you only write down the imaginary part. Okay, so arithmetic of complex numbers. This should be fairly easy for you. This is what we just said earlier. Oh, we haven't said this earlier. Okay, so a new word. It's going to be on the next page. They're going to ask you, what is the conjugate? The conjugate is when I have my two roots, and when the only difference between this one here and this one here is the sign. That is the only difference. It's the same value of A, the same value of B. Okay, so to find the conjugate, you simply change the sign of the imaginary part. Okay, now set that aside for a second. If I want to simplify this, in algebra we learned we can combine our like terms. Right? 2 minus 3 is going to give us negative 1. A plus 4a is going to give me 5a, and we just have a 3b. Right? Same thing works for imaginary numbers. We've got our 3 plus the 4 gives us 7, and our 2i plus 5i gives me 7i. Okay. All right. So we know that A is equal to this, B is equal to this, And so if I want you to calculate a plus b, I'm going to have 2 plus 3, which gives me 5, and 3i minus I is going to give me 2i. If I want you to calculate b minus c, I'm going to have my 3 minus negative 4 is going to give me 7, and negative I minus 2i is going to give me negative 3i. And 2a, I'm just going to take this and multiply it by 2. So 2 times 2 is going to give me 4, and 2 times 3 is going to give me 6i. Okay. And there's no numbers here. They just want you to do it theoretically. You copy this down. Okay. So we're just combining like terms. Okay. Now, 3 is pretty important. Okay, this is 3. Okay. So, you do 2 times 1 is going to give me 2. 2 times 2 square root 2 is going to be 4 square root 2. Negative 3 root 2 times 1 is going to give me negative 3 root 2. And negative 3 root 2 times 2 root 2 is going to give me 6 root 4. Okay. And 6 root 4, square root of 4 is going to give me 2. And then that simplifies to give me 12. So now I've got 2 minus 12. That's going to simplify to give me 10. And we've got square root of 2. Okay. Same thing applies when I've got 2 minus I times 3 plus 2i. We do our FOIL line. So 2 times 3 is going to give me 6. 2 times 2i is going to give me 4i. Negative I times 3 gives me negative 3i. And negative I times 2i gives me negative 2i squared. And then the I squared is going to change to negative 1. And negative 1 times negative 2 is going to give me positive 2. And now we've got 6 plus 2 is going to give me 8. So I end up with 8i. Okay. So, so here you want to check your work for this. Now, what we have here, 4a, is a very important thing. Notice how, I'm going to zoom in because this is so important. Okay, so this is 1 plus 2 square root 2, and this is times 1 minus 2 square root 2. So we've got a conjugate here, right? The only difference between these two things are the sign. And so let's watch what happens. 1 times 1 is going to give me 1. 1 times negative 2 square root 2 gives me negative 2 square root 2. 2 square root 2 times 2 square root times 1 gives me positive 2 square root 2. And 2 square root 2 times negative 2 square root 2 is going to give me negative 2 square root 2 times 2 square root 2. So I've got 2 times 2, which is going to give me 4, and 4 times radical 2 gives me 8. Okay. You know, somebody asked me to do this in class. I'm going to do it. Okay. 2 radical 2 times 2 radical 2. What does that mean? So this is same thing as 2 times 2 times radical 2 times radical 2, right? Radical 2 times radical 2 is square root of 4, which is simply 2. So then we still have the 2 here and the 2 here. So we end up with 2 times 2 times 2, which is equal to 8. Okay, that's where this 8 comes from. Okay, so we have 1. These things cancels out because I got negative 2 radical 2 and positive 2 radical 2. That's going to cancel out, and then we end up with 1 minus 8, which gives me negative 7. Now notice, this is positive. There's no radical. Notice, no radical in answer. Okay, so show how to show that this is equal to this. So basically, what we're doing is we've got our plus symbol here, right? So now I'm going to change it to a minus, and what we have here, what I'm highlighting in green, this is the conjugate, right? So we're going to multiply we're going to multiply the top and bottom of this equation by the conjugate of the denominator. This isn't quite complete yet. So we're going to multiply the numerator and denominator by the conjugate of the denominator. That part is important, isn't it? So if I multiply the top and bottom by the conjugate of the denominator, we already know this is the answer from part A, right? The answer from part A is -7. So I'm going to replace this here with -7. And then I need to FOIL the top part. So 2 times 1 gives me 2. 2 times -2 radical 2 is this. -3 radical 2 times 1 is this. -3 radical 2 times -2 radical 2 is going to give me this. Okay, so then 6 times 2 is going to give me 12. We simplify a little further. And I've got 2 and 2 and 12. That's going to give me 14. So I end up with 14 minus 7 radical 2 over -7 radical 2. Okay, so I end up with -2 plus radical 2. And hence we have just shown it. Okay, so this applies the same thing with I. So if I've got 2 minus I plus 3I -2, I'm going to multiply the top and bottom by the conjugate of the denominator. Okay, so we end up with, let's do the denominator first. 3 times 3 gives me 9. 3 times -2i gives me -6i. 2i times 3 gives me +6i. And 2i times -2i is going to give me -4i squared. Okay, so we know this -6i and +6i is going to cancel out. And -4i squared is going to be -1. So -1 times -4i, this is going to turn into +4. Okay. My numerator, 2 times 3 is going to give me 6. 2 times -2i gives me 4i. -i times 3 gives me -3i. And -i times -2i is going to give me +2i squared. Okay. And then the +2i squared is going to turn into -2. And now we combine the 6 and the -2 to get 4. Okay. I only did A divided by B and B divided by C. If you want to do this one, you can do that on your own. Hit pause if you need more time on this. Okay. So, combine like terms, and we use the conjugate to solve these. Okay, now I'm going to show you how to do these problems on using the calculator. Okay, so my calculator instructions are right here. Okay, instructions are pretty simple. I'm going to do this in a separate video. Okay. But anyways, if you use the calculator steps, you get these answers. Okay, this says the imaginary part of this plus this equals 0. So let's do that. So we know we know Z1 is this. And we know Z2 is this. Okay. So Z1, I'm just rewriting it, is 2 plus 3i, right? P times Z2 is going to give me P3 minus Pi, right? Because it's 3 minus I. Okay, and we're just multiplying P times each of those things. All right, so now we're going to combine our like terms. So we've got the number 2, and we've got P3. So these are our real terms. And then we've got 3i and negative pi, which simplifies to 3 minus p in parentheses times I. So this is our imaginary part. And they've just said that our imaginary part is equal to 0. So I'm going to make 3 minus p equal to 0. And then so p has to be 3. Okay. Okay, people had trouble with example 6. One of the solutions of x squared plus px plus q equals 0 is 2 minus 3i. So this is one of the roots, right? Or one of the solutions. So that means the other solution is going to be the conjugate. So the other solution is going to be 2 plus 3i. Okay, so just a side note, because I think people really were struggling in this. So if I've got x minus a times x minus b equals 0, that means one of the solutions is equal to a, and another solution is equal to b. Okay, does that make sense? X minus a, one of my solutions is a, and x minus b, one of my solutions is b, right? Because b minus b, that's going to give me 0. A minus a, that's going to give me 0. So if I look here, if one of my solutions is 2 minus 3i, then this solution here has to be, I have to have x minus that thing. And if my other solution is this, then I would have to have x minus that thing. Okay. Okay, I hope that sample example made sense. Okay, so then we FOIL. X times x gives me x squared. So just check your work here. And then the like terms cancels out. Minus 3ix plus 3ix, that cancels out. Minus 6i plus 6i cancels out. And we have negative 9i squared. So then our equation simplifies to, we end up with x squared. Okay, I've got minus 2i, that's going to give me minus 2x, and minus 2x is going to give me minus 4x, and then plus 4, and this here is going to give me plus 9, which is going to give me plus 4 plus 9 is going to give me 13 equals 0. So when I've combined our like terms, we've got x squared, negative 2x, and negative 2x gives me negative 4x, and 4 plus 9 is going to give me 13. So if p is the coefficient in front of x, p is equal to negative 4. If q is the coefficient in front of the constant term, then q is going to be 13. Okay. Find your exact solutions. You may want to hit pause. Okay, I'm going to move it up. You can hit pause. And the calculator stuff I'll make in a separate video.